Hey there and welcome. Today, we're going to tackle writing linear equations, but we're going to learn the fast way, the efficient way. If you've ever felt like you're jumping through a bunch of hoops just to get an equation, well, this one's for you. You know that feeling, right? That whole song and dance of finding the slope, plugging in a point, grinding through the algebra to solve for b, and then rewriting the whole equation all over again? It's a process. And honestly, it's kind of slow. What if we could just skip most of that? So here's our game plan. We'll do a quick look at the old slow method just to set the stage. Then we'll introduce a much faster way forward. We'll see it in action with a few examples, point out some common traps so you can avoid them, and wrap up with why this method really matters. All right, before we get to the shiny new thing, let's take one last look at the method we're all trying to get away from. Yep, this is the one. It's this whole multi-step dance that, yeah, it gets the job done, but let's be real, every single step is another chance to make a tiny little algebra mistake, and it just takes up so much time. Okay, let's get to the good stuff. There is a much better, much faster, and way more direct way to do this, and it's called the point-slope form. This thing is an absolute game changer. And here it is. This little formula is going to be your new best friend. Y minus y1 equals m times x minus x1. It looks simple, and that's because it is simple. All you need is exactly what the name tells you. A point, that's your x1, y1, and the slope, which is your m. That's it. Now, the real beauty here is that it's basically just fill in the blanks. You just write down the skeleton of the formula, you plug in your three numbers, your y value, your slope, your x value, and that's it. Step 3 is not a joke. You're literally done. No solving, no rearranging, just done. All right, enough talk. Let's actually put this formula to the test and see it work its magic. Okay, let's start with a nice, simple one. We've got a slope of 4 and a point at 2, 5. So our m is 4, our x sub 1 is 2, and our y sub 1 is 5. We just drop those numbers right into our skeleton. The y-coordinate, 5, goes on the left. The slope, 4, and the x-coordinate, 2, go on the right. And boom! Y minus 5 equals 4 times x minus 2. That's the final answer. No extra steps needed. How great is that? Okay, let's level up a little bit. What happens when we throw some negative numbers in there? Because they always try to trip us up, right? This time, our slope is -3, and our point is -1, 4. We do the exact same thing. Plug it all in. We get y minus 4 on the left, and on the right, our slope of -3 times x minus -1. Now, the only thing we have to do here is a tiny bit of housekeeping. Subtracting a negative is just adding, so we clean it up to y minus 4 equals -3 times x plus 1. All right, now for the final boss battle. What if they don't give you the slope? What if they just give you 2 points? Let's say 1, 3, and 5, 11. Well, first things first, we need our m. So we just use the good old slope formula, change in y over change in x. That's 11 minus 3 on top and 5 minus 1 on the bottom. We get 8 over 4, so our slope is 2. Now we've got our slope, and we've got 2 different points we can use. And this is what's so cool. It does not matter which point you pick. Watch. If we use 1, 3, we get y minus 3 equals 2 times x minus 1. If we use the other point, 5, 11, we get y minus 11 equals 2 times x minus 5. And guess what? Both of those equations are 100% correct. Now, this method is pretty amazing, but there are a couple of little traps that are easy to fall into. So let's make sure you can see them coming and just walk right around them. Okay, trap number 1 is the urge to do too much work. I know, it's tempting to distribute that number and simplify it. But if the question specifically asks for point-slope form, you stop right after you plug the numbers in, you're done. Doing more could actually get you the question wrong. And that brings us to the second trap, which we saw in that last example. Don't panic if your answer looks different from your friends or from the answer key. As long as you use the right slope and a valid point, your answer is correct. Think of them as synonyms. They look different, but they describe the exact same line. So why did we even learn this? Is it just some neat little math trick? No way. This is actually a professional grade tool. You know, when you get to higher level math like calculus, every second counts, and this is the form they prefer because it's just faster. It's also all over computer graphics. Think about it. A line on a screen is defined by 2 points, 2 vertices. The computer doesn't care where the y-intercept is, especially if it's 1,000 pixels off the screen. Point slope lets you work directly with the points you actually have. So there you have it. You've just learned the method that actual mathematicians and programmers use because it's direct, it's fast, and it's powerful. This is the pros method. The only question left is, are you ready to use it?